Alright, so for UBFPM.1, I have a box that's being pulled with 200 newtons at a 40-degree angle, and the box weighs 20 kilograms. And my system schema, there's a friction force and a normal force between the box and the ground. There's a gravitational force. Oops, I forgot to put that in there. There's a gravitational force between the box and the earth, and a tension force between the man pulling it and the box. So my force diagram would look like this. This is my normal force. Oops. The normal force, and because you have to split this degree or this angle into fx and fy, this would be our fy, this would be our fx, this would be our gravitational force, and it would be a little longer because it has to add up, or I guess the normal force and the Fy has to add up to the gravitational force, and then the friction force would be there. Okay, so first what you would do, I guess just to write these down so I don't forget. Whoa. Okay. Normal force plus your Fy plus the gravitational. Oh my god. Gravitational force would all equal 0 because they're all the vertical forces, and then same with your force of friction and your F of x would also equal 0 because they're the horizontal forces. So what I did first, to find your gravitational force, it would be gravitational force equals mass times little g, which is 9.8. So for gravitational force, you would just plug in 20 for the mass and 9.8 for little g. And you're only using 2 sig figs because that's what was given in my problem. So the gravitational force would be negative 196, but because it's 2 sig figs, we make it negative 200. Then you solve for fx and fy using sine and cosine. So to solve for fy, you would do the sine of the angle is equal to fx fy over your force. So the sine of 40 times 80 is 51 newtons. And then you use cosine to get fx. So we'll do the cosine of 40 equals fx over 80. Cosine of 40 times 80. So fx equals 61 newtons. And then you know that the friction force, or the normal force, I mean, is equal to, you can use these, or this equation to find your normal force because that's your unknown. So you would plug in 51 for Fy, and you would plug in negative 200 for gravitational force set to 0. When you add those two together, you get F normal force plus, or minus, minus 149 equals 0. You would add 149 to both sides, which would mean that your normal force would equal positive 149, no, 150, because of 2 sig figs, you would just round up to 150 newtons for your normal force. So knowing that, you can use this times your coefficient, which is 0.15. The coefficient of friction is 0.15, so you would do your friction force equals mu, which is 0.15, times the normal force, which we found was 150. When you multiply those together, we would get 23, but it's negative because it's going to the left. It would be negative 23 newtons. And then, to find your acceleration of the box, you would essentially add all the forces up, but we know that when you add the vertical forces, they would all be 0, so that would be kind of pointless, so you would just add the Fx and force of friction forces together, so we would have Fx plus Fy equals mass times acceleration. You would plug in 61 for Fx, and you would plug in, this isn't supposed to be Fy, this is supposed to be F, so friction force, this is friction force. Change that. So, and we found that the friction force was negative 23, and our mass was 20. So when you add these two together, we get 38 newtons equals 20A. To get A by itself, you would divide both sides by 20, and we would get that the acceleration is 1.9 meters per second squared. And that's UBFPM 1.